For this class, you're expected to know three Maclaurin series. Maclaurin meaning they're centered at 0. You need to know e to the x, sine x, and cosine x. All three of these converge from negative infinity to infinity, so they're incredibly useful in that sense. So if we look at the function e to the x, I know that it doesn't actually have symmetry, so it's not even, it's not odd. It's also always positive, so this one will not alternate. So we've looked at the Taylor polynomial e to the x before, so we know that it's 1 plus x over 1 factorial, and this was 1 over 0 factorial, plus x squared over 2 factorial, plus x to the third over 3 factorial, and I'm going to write out 4 terms plus my ellipses. Now this can be derived very simply. You just take derivatives of e to the x, which is always e to the x, and then we're centering it at 0, so e to the 0 is 1, which is why all your coefficients are 1. Now this is going to equal the sum from n equals 0 to infinity, and if you take a look, this one's very simple. This is a 1 factorial and a 0 factorial, so I'm going to have an n factorial in the denominator. 0 factorial, then it changes to 1, 2, to 3. My powers of x's are the same as the factorial, so I'll very simply have an x to the n in the numerator, and you can plug in values of n to check. And again, this converges on negative infinity to infinity. Sine x has symmetry. It is symmetric about the origin. So this is an odd function, so we talked about this in class. Only the odd powers will be there, x to the first, x to the third, x to the fifth. It will also alternate, just like sine does. It goes positive, negative. So we'll start with x to the first, which is just an x. Then we will subtract, because it's alternating, x to the third over 3 factorial. And remember, it's odd. 1, 3, the next one will be 5, but it's alternating, so add x to the fifth over 5 factorial minus x to the 7th over 7 factorial plus, put your ellipses, equals the sum, and again this starts with n equals 0 to infinity, and we do have a fraction. The first thing I'm going to deal with is the fact that this is actually alternating. It starts positive, then negative, positive, negative. So I'm going to put in negative 1, and I'm going to start with n and check and see if this matches. If it doesn't, I can change it to n plus 1. So negative 1 to the 0 is positive 1. That's a positive coefficient. Negative 1 to the first is negative 1, and there's my negative coefficient. So this negative 1 to the n will match. Now if I look at my powers of x and my factorials, they are the same, and they're also odd. So odd numbers are usually of the form 2n plus 1 or 2n minus 1. That will keep it odd. So I know it's x to the 2n, and then I'm going to have to add 1 or subtract 1. So I'm going to start with my 0. I'm going to plug in 0, and I need to get 1. So 2n, 2 times 0 is 0. I'm going to add 1, and then I'm going to check on my next term. So when n equals 1, it's 2 times 1 plus 1 is 3, so this will work. And that means my denominator will be 2n plus 1. It needs to be in parentheses, factorial. And just like e to the x, this converges on negative infinity to infinity. Now cosine x is an even function. So it is symmetric about the y-axis, and it's going to have even powers, x squared, x to the fourth, x to the sixth. We're also going to include the x to the 0th, or just 1. It's also alternating, just like sine, so it's 1 minus, and then even, so x squared over 2 factorial, or just 2, plus x to the 4th over 4 factorial, minus x to the 6th over 6 factorial, plus, and then put our ellipses on. This will equal the sum from n equals 0 to infinity, and again it's alternating but starts positive just like sine does, so my negative 1 to the n will work. And then my powers of x and my factorials match, but now they're even. So when n equals 0, it's just going to be a 0 factorial, but when n equals 1, it's 2 factorial. When n equals 2, it's 4 factorial. So even numbers are written of the form 2n, and that works for this series. So I have x to the 2n, and then in parentheses I have 2n factorial, and you can plug values in to check. E to the x, sine x, and cosine x all converge from negative infinity to infinity, so they can be used to approximate the function at any x value.